Awesome. Thank you so much, Zoe. Everybody, we're glad to join with you again here on Tuesday morning for another session about implementing solar into your architectural roles here. A quick refresher on Melink Solar. We're based here in Cincinnati, Ohio. We'll get into a little bit more here as Monica and myself are presenting along with Nathan Young here. So today we're covering a few more topics and knowledge objectives for you guys to earn your CE for AIA here. We'll be going through how you can actually reduce the carbon offset of a building by using solar. Talk a little bit about how you can compare solar costs versus the grid electricity costs. Go into then designing solar for new builds so that you make a solar ready roof. And then finally here, how we can update a current structure through renovations and also make that roof solar ready. So I want to kick it off there by reintroducing Monica Niehaus and letting her give a quick reintroduction for anybody that did not join us last week.
All right, thanks, Chris. Good morning, everyone. Thanks for joining. My name is Monica Niehaus, and I've been with Melink Solar for almost 6 years now. Like he mentioned, we're based here in Cincinnati, and we've been specializing in commercial solar roof mounts, ground mounts, and parking canopies. I work with leaders of organizations like P&G, FedEx, Amazon, DHL, universities like UD, Miami University, and Kent State, and help them kickstart their solar journey. Run the financials and the ROI to as they're considering it. And then I'll kick it over to Nathan Young.
Hello all, Nathan Young, principal engineer here at Melink Solar. Been involved with many different solar projects as far as canopies, roof mounts, ground mounts, different roof types, different building constructions. Very familiar with structural and electrical aspects of the solar projects and what it takes to get those projects done.
And I'm Chris Seguin with Melink Solar. I've been with the firm for just about a year, but been within solar for 3 years or so. Just like Monica, I get to work with different leaders across organizations in Ohio and the Midwest considering solar. Everybody from your facilities managers all the way up through CEOs, and understanding the different needs for each solar project goals, as well as how it will impact their facility and their overall operations.
And a little bit of background about Melink Solar again. It was started back in 1987 by Steve Melink, initially as an HVAC testing and balancing firm. There was a lot of energy efficiency. He eventually developed a product used in commercial kitchens across the world now. And when they were building out the first headquarters in 2006, the goal was to be the first LEED gold building in the state of Ohio. And eventually, by adding different types of solar PV technology, they eventually became LEED Platinum, which was one of like 27 buildings in the world at the time, and achieved net zero energy between geothermal and different types of solar that you see there in that picture. And along with that, with owning and operating solar, we kickstarted the business unit. So our first solar projects began in one of the more well-known projects back in 2010 was with the Cincinnati Zoo. So the first canopy project, and at the time we were not only owning and operating solar, but we were designing and building like we are today. Eventually, we began working with developers and larger independent power producers who act as the PPA owner, and then they hire us as the EPC or the engineering procurement construction firm. In 2019, that was at the time our largest project that you see there in the middle, 15 megawatt project in Piqua, Ohio. And now we're recognized as one of the top engineering procurement construction firms for commercial solar in the Midwest. And then the video that you see there, or the picture hovering over both parking canopies at the Cincinnati Zoo, that was phase 2 that we completed last year. And the technology has really advanced and matured over the past 15 years. So it's been really cool to see those two projects come to life. Two of many projects that we've done with the Cincinnati Zoo, and that one that you see there was awarded the Solar Project of the Year award by Solar Builder magazine.
And so like Monica said, Melink Solar has been recognized as the #1 solar engineering procurement construction firm across Ohio and the Midwest for many years running now, and I'm very proud of our ranking as the #7 across the country. We work with a lot of different types of customers, from those utility scale development firms, as well as a significant amount of Fortune 100, Fortune 500 companies, like some of the brands that you see here. Right now, we've got over 60 different projects in flight under construction, ranging from different sizes. And as the map shows you in those green dots, especially with our direct to customer or commercial projects, we like to work within Ohio and within our backyard here in the Midwest. Very focused on supporting the growth of this region, and especially our partners across everywhere within Ohio and our neighboring states. So we'll kick it off here, getting into the first learning objective, where we are reducing scope 2 emissions with solar. Now, we know that achieving low carbon footprint buildings, or even a net zero building, always needs to begin with those early stage design considerations. Buildings across the globe contribute to around 40% of global greenhouse gas emissions annually. So those early decisions that you might be making as an architectural or engineering firm can really make a big impact on the overall carbon emissions across the world. Architectural considerations like orientation or envelope are already being considered when there's a goal for low impact buildings. And so if solar is in the mix, then considering the solar goals and how your design changes can impact solar energy production. And it will play a big role in what the solar system can actually do when it's built. Solar systems can often help projects, architects, and firms also earn recognition. You see some of these up here, like LEED or Energy Star, and then earn those accreditations for those buildings. Like Monica mentioned, we have here, at Melink HQ with the LEED Gold and LEED Platinum building. Now, remember that you're not alone. Because so many organizations are looking at lowering their greenhouse gas emissions, a lot have lofty goals and want to drive those lower impact net zero buildings. So many of these organizations have produced some supporting materials that you can use as architects when you start new projects and are considering what that impact will be. AIA actually worked with the Carbon Leadership Forum to develop the Embodied Carbon Toolkit, which is linked here on the screen and shown in some of those images. So you'll be able to navigate to that website or click on these links when the slides are delivered later on. But also, don't forget solar EPCs, because coordination with firms like us will be the best guide when you're actually designing those buildings or any type of renovation, because solar will be so specific to the engineering sets that we design and report that accurate clean energy production is going to be necessary when you're actually going forward into the audit stage, or maybe if you're looking at finding a grant that's helping support the development of the project. You want to make sure that you're working with accurate solar engineering design sets instead of maybe using some default systems that are built within other types of softwares. So when talking about carbon offset and an organization's carbon footprint, most things are referring back to the Greenhouse Gas Protocol, which is recognized worldwide, and 3 different types of carbon emission scopes there that Monica will walk through.
So scope 1 emissions that you see there come from owned or controlled sources. So solar doesn't impact that. Think of, your overall facility, your equipment, your vehicles, that all of that, those owned assets that you have. And then scope 2 is where solar comes into place, because those are the indirect emissions from the generation of purchased or acquired electricity. So that electricity from your utility, or if you're working with a supplier, and when you use on-site solar, you're directly impacting the amount of energy that you're pulling from the grid there. So scope 3 emissions, think of all other indirect emissions. So think of your supply chain, other investments that are made. You have to really think holistically. Some of our clients in the past have done this, like P&G is a good example, where they were challenging their supply chain to help meet their net zero energy goals. They can only do so much internally. They can only, put so much on-site solar on their facilities. Another portion would be, purchasing those RECs, and then lowering their energy consumption from their, from their facility. And then, again, hopefully, challenging the supply chain to take some efforts as well, so that they can capture that, into their overall scope emissions.
Now, behemoths like Procter and Gamble are able to kind of tackle all these different scopes, but a lot of smaller organizations are going to look to some of the simpler tasks up front, maybe with a little bit of energy efficiency upgrades, but also looking at scope 2, because scope 2 emissions are going to be the fastest, easiest way to cut carbon emissions overall without disrupting the major processes of a facility or the overall consumption, or reducing any quality in the work that they're doing in that facility. Now, as we get into how solar actually reduces carbon emissions at the facility, we need to remind everybody just quickly how solar works in behind the meter solar systems. So remember that it's the photovoltaic effect that creates DC or direct current energy from sunlight when it hits those solar panels. Then when solar inverters take place, Monica will go through that.
Yep, so as the sunshine rains the photons onto the solar panels, again, that creates the DC electricity. You have the inverter, which is another key part of the system, and that turns that DC power into alternating current, or AC. Depending on how large the system is and how many inverters are needed, sometimes there's an AC combiner. And oftentimes, whether we're working with existing or new builds, understanding how that's going to go into and connect into the electrical room, sometimes that is running on the side of the building, or sometimes it needs to be, through the top of the roof. So you also have the safety and monitoring component. So you have the disconnect. The firemen are trained to make sure that if there's ever a need to turn off the system, they're, again, they're trained to handle that with that disconnect switch that is easily accessible. Wherever there are loads from the building, that's where solar will provide power. Ideally, we're working with just one point of interconnection to reduce costs instead of tying in behind multiple meters. And then you have that monitoring capabilities. When we're providing the turnkey costs, the monitoring and all the equipment is included, so you can access the monitoring from your laptop or from your cell phone. And then finally, if the building does not need all of that solar power, if the solar system is producing more energy than what the building needs, then that bi-directional meter that is installed in the process, it will actually spin backwards, and then you are credited by the utility, depending on the net metering rules, for that excess electricity that gets delivered back to the grid.
And when we talk about how solar lowers that carbon footprint of the building, we need to remember that solar energy production is actually measured in kilowatt hours and not kilowatts, like the equipment is rated in. So kilowatts and kilowatt hours are related terms, but they are unique. A kilowatt measures electricity at a specific instant, while a kilowatt hour measures electricity over time. Understanding those differences between kilowatts and kilowatt hours is very important when you consider design concepts, because we need to size the system to meet the facility's energy needs with the safe and cost-effective design, and actually matching that kilowatt hour usage.
And this is a fun graphic, so to look at it in another way, think of kW as the power of the car, and kWh or kilowatt hours is the distance that the car actually travels. So here we have two cars traveling the same distance, but over different periods of time. So that blue car on top is less powerful and it travels slower at 10 miles per hour for the 100-mile journey. And then the red car, it has more power and it travels at 100 miles per hour, getting it to the 100-mile mark in just 1 hour.
Now, tying it all together here, we know that replacing grid energy produced by traditional energy sources with solar is, lowering offset carbon emissions. But by how much is that actually lowering those? So it's known out there that traditional energy sources typically will produce 0.394 kilograms or 0.000394 metric tons of CO2 when energy is generated by those traditional sources like natural gas or coal.
And then with on-site solar, energy is produced by the system and it's used as the facility reduces or entirely replaces the grid energy carbon footprint. So even when the solar system's not producing energy, like at night, or as much energy in the winter months, a system that's sized properly will produce enough energy over the course of a year to offset the grid energy used by the facility. So there to the right, you can see, so this is just a sample of the typical feasibility analysis that we put together. So this system is sized to produce more energy than what the facility consumes over the course of the year. So in the black bars there, that's the energy usage. We get this from the latest 12 months of electric bills. Or if it's for a new build, we will have to make some assumptions, or we rely on you from with guidance from consultants based off of what the expected use of the facility will be. And then you can see there that, over the winter months, solar is only providing about half of the energy usage during those months, but the summer months more than make up for it. And that's where net metering comes into place. That's where understanding any net billing or net exporting and utility constraints is really important when we capture the financials and the ROI for exporting that much energy.
Last week, we talked a little bit about the different components of the solar system, and we mentioned today that we would explain why it's typical to see a system with a higher DC to AC ratio. That is those power ratings of those solar panels in watts DC versus the power ratings of the inverters in watts AC.
And it's standard practice to design the solar system with a higher DC rating than AC. That's because the solar panel power ratings are based on the panel producing energy at these ideal conditions, which happens so rarely. Think of when the sun is perfectly over the panels and it's the perfect weather, it's a perfect amount of radiance. So matching the AC rating to the DC rating just means more inverters need to be purchased and installed without necessarily delivering more of that usable energy. So solar firms will value engineer the system to deliver the most kilowatt hours instead of the most kilowatts while maintaining a cost-effective design.
I remember that buildings with a behind-the-meter on-site solar system are still going to be connected to the grid, and they're pulling from the grid at night or during those low production times when the clouds are out. So adding batteries that store excess energy produced by that solar system can be a solution that lowers the carbon footprint of a building even further, so that the building uses that energy during those times instead of grid energy.
And by using this excess solar produce energy, the battery systems help increase the overall solar consumption, which directly reduces the carbon emissions that would otherwise come from using grid power. Moreover, batteries today are helping building energy strategy by providing demand response and frequency regulation or load shifting, which allows the buildings to run more efficiently. We don't typically see many batteries added to solar systems around the Midwest because the cost tends to outweigh the benefit at this time. However, manufacturers are hard at work to develop and manufacture and deploy lower cost battery energy storage systems for commercial use. Nathan, do you want to kind of talk about some of the battery storage systems that we've paired with solar in the past? I know there haven't been a lot in the Midwest, but we've seen it more on the East and West Coast where demand charges are high.
Correct, yeah, we've worked on some projects in Massachusetts, Colorado, some other areas of the country, Hawaii. But we're seeing that that's making more sense now with rising utility rates. So the demand piece reduction is a little more helpful. And if you compare that with the grid services that Monica talked about, it's a little more cost effective now than it was just, a year ago.
Which leads us right into how we actually look at the cost of solar. And comparing solar costs versus grid electricity costs is really the main driver behind anybody making a decision to move to solar. So it all starts with the cost of that solar project to understand what is this investment up front. And like with a lot of other construction projects, there's many different costs to consider that all roll up into the overall project cost or budget, and these are going to come with both soft and hard costs.
Yep, and every project really is different. I mean, there's no blanket approach that we can take to every project. Every project will have a unique budget. The approach will be different. As an example, smaller ground mounts are going to be cost prohibitive compared to a roof mount. Usually, and that's because with ground mounts, you typically still need the fence, paying for pile driving, the steel racking system into the ground. Typically, we see costs coming from engineering work, equipment costs, permitting and inspection costs. And then you have those labor costs and then those soft costs that come from insurance, legal, or financing. And then with the renovation projects, there may be added cost to upgrade the roof or improve its structural capacity. In the past, where after a structural analysis for an existing building, if it comes back, saying that the building can't support that weight, we haven't seen a lot of building owners add that extra infrastructure. In most cases, what we've done is downsize the array or spread out the array. Depends on, the size roof that we're working with and the energy usage, and the sizing goals of the customer and how much energy that they want to offset. But at the end of the day, we need to make sure that the integrity of the roof structure is maintained.
Now, remember, there are still federal solar investment tax credits that can be applied to a commercial solar project. See in the upper right-hand corner here, a timeline of the viability or eligibility of applying those tax credits to different projects. That's going to depend on the project size here. Beyond that base federal tax credit, we have those 3 bonus tax credits that we discussed last week. Those are going to be available to different projects based on where they're located or what equipment was used to build the entire solar system and if it was manufactured within the United States. Another federal option is the depreciation here, which reverted to a 100% bonus depreciation in year 1 for solar projects after the enactment of the One Big Beautiful Bill Act over the summer. And then also, like other asset classes, solar can be depreciated through state depreciation as well, lowering that net cost of the upfront investment.
So we have a really unique window, time frame here with the 30% tax credits. Chris mentioned with the Big Beautiful Bill, we kind of have an expiration date on that now. You may know that residential tax credits are expiring at the end of this year. And then for the tax credits for commercial size projects, what a lot of customers are doing it's safe harboring or spending 5% of the project cost before July 4th, 2026. So that there's no place in service deadline. Or as long as that project is placed in service within 4 years, then you're still eligible for the credit. Whereas if you start construction or spend 5% of the project costs after that July 4th, 2026 date, then you have an extra tight window to finish the project. It needs to be completed and placed into service by the end of 2027. So again, we're, if this is something that your clients are considering, definitely let them know of that window and that opportunity to safe harbor. Again, with electricity rates going up right now, it's a really good time paired with all of these incentives available. We also have what's called RECs. You may have heard of them, or SRECs, solar renewable energy credits. And these are generated by whenever you have a megawatt hour of energy produced by the system. So think of this as your environmental credit of the system, totally separate from the electric bill savings. And this is an option available in states like Ohio, and Pennsylvania, parts of Kentucky as well. And it's basically like adding a new revenue stream that's created because of the state renewable energy portfolio standards. And remember that different states, local or utility funding options may be available to solar projects that help shift the investment burden from the owner to other areas. In Pennsylvania, I know there are some utility specific incentives. If a cash purchase doesn't make sense, then there are a number of financing ways that we can structure. We work with multiple partners specifically to support the investment in clean energy projects like solar. And this can include different types of loans, PACE, which is property assessed clean energy, or PPAs, or power purchase agreements. And that's where a third party owns and operates the system that's connected to your facility. And then they sell that energy that's produced by the system back to that owner for a certain dollar per kilowatt hour rate. Ideally, it's cheaper than grid energy, and it's looking pretty optimistic with how rapid the rates have been increasing.
Now, once the cost of that solar project's determined, you need to compare it against that grid energy cost. And because solar systems will produce energy for at least 30 years, according to the production warranty, but really continue to produce beyond there, a fair comparison against grid energy must consider that current grid cost and then its escalation rate over that 30-year lifetime. Solar is an attractive investment for many because of that assumed increase in grid energy costs coming to us right now, like you see in the right-hand corner for what happened in Ohio in June of 2025, but also looking out into the future.
So when you look at the graph on the screen, it shows the historical Ohio and national commercial electricity rates. And there are two takeaways here that stand out. So over time, the cost of grid energy goes up. And when that happens, it goes up pretty drastically. So right now we're experiencing those drastic increases. And recently we've seen a large increase in grid energy costs across the state and the nation. And this is mostly driven by the capacity pricing that comes down from the regional transmission organizations. Capacity auction, our regional grid operator is PJM. And last summer we saw over 800% increase in capacity pricing. And that was in the RTO that serves Ohio and parts of Kentucky. So if you haven't noticed, take a look at your June bill, and more than likely those energy prices have jumped. And we're seeing supplier rates renewed, and those rates are going up between 30 to 50% in a lot of cases. So even with the need for capacity being driven mainly by the growth of AI and new data centers, as you've likely heard, there are many other reasons that the grid energy cost is expected to continue climbing in the future. Just to name a few, the the grid is old, it's aging, and our infrastructure needs a lot of replacements and a lot of upgrades to keep up with this modern world that we're in. So investor-owned utilities have ignored this need, and they're gonna, pass those costs on to their customers, or, all the ratepayers. And so all of us are gonna have to deal with the burden of this. And then as fossil fuels becomes more and more rare, supply and demand takes over, leading to increased costs, and there's all these geopolitical events that drive it up higher as well. And as we saw in Texas just a few years ago, weather events can dramatically impact the cost of energy. And these are, things that it's really just hard to predict, but they impact entire states or entire regions.
Now, ultimately, that choice to go solar typically is driven by the financials. Different customers will consider different types of financial metrics when they're weighing that solar investment against staying with grid energy only. So it's always important to understand what data points that customer is going to be looking at to consider solar, and that the financials are laid out accurately for their analysis.
And one metric that is sometimes overlooked is called LCOE, or levelized cost of energy. And that's the total cost of an energy source divided by the amount of energy produced in its lifetime. So in this example, you take the net system cost after incentives, and after, any costs of maintenance and inverter replacement around year 15. And you take that net system cost divided by the 30-year energy production in kilowatt hours over the lifetime. So net system cost divided by total kilowatt hours produced, and that gets you the levelized cost of energy. And oftentimes, our solar discussions really focus on this levelized cost of energy, or LCOE, to consider this large upfront investment cost that is providing energy for a long, long time. And because the cost of grid energy is unknown, though we all know that it's going to continue going up over time, it's important to align up front on the annual escalation rate that's used in the analysis, just to provide an accurate comparison. So we're always upfront, with the assumptions that we put into the analysis. Sometimes the customer comes back and say, hey, let's see what the difference is between a 5% escalator or an 8% escalator versus, that historically what we've seen for Ohio is closer to 2 to 3%. So all of those considerations, as well as federal income tax rate, which affects the bonus depreciation, and then you have your discount rate as well, that ties into net present value and internal rate of return. So again, lining on these assumptions upfront will be key here for providing an accurate analysis. A lot of the times our customers are running their own internal analysis. We can provide the Excel spreadsheet for a lot of those inputs. And like Chris mentioned before, we're really taking a very detailed approach to understanding the electric bill charges that will be impacted with solar.
And maybe that's a good time to lead into Fernando's question there, Monica. So obviously there is a bunch of assumptions that we can tweak to get that your payback period. Here on this graph, it's showing a 4.9 year payback. This, I don't know what the system size or where that data was pulled from. I don't know if you have that, Monica, but that's probably roughly a half a meg rooftop project, I would guess. So you're looking at a payback less than 5 years, and depending on if the system is 4 times that size, the payback goes down. If it's much smaller, that payback duration period will go up. Based on some of those assumptions that Monica just mentioned, and we can dig into more specifics maybe at the end on that.
Yeah, it depends on the size of the system, the scope. I mean, if it's a pitched roof, what's can we really use a south facing roof, or is it east west facing? All of that really determines the payback here. And again, there's no blanket approach that we can use for any system. I know a lot of people out there are using just like a rough $2 or $3 per watt cost for any size system. But that's really not the case, and we'll dive into like the details of, okay, are we dealing with a pitched shingle roof or a standing seam metal roof or a flat white membrane roof, and then what type of ground mount system as well. We've done like the ballasted systems for ground mounts where we're not, pile driving into the ground. But yeah, I mean, right now, again, in this like unique window of time where you can still monetize those tax incentives, it's very common to see around a, 5-year payback, sometimes even less. S corps tend to be tend to like monetize a lot of incentives with their high federal income tax rate. And then that's where the 100% bonus depreciation also comes in as well.
Yeah, obviously, like your canopies are the most expensive to build, so those are gonna see significantly longer payback periods. Your ground mounts are a little closer to a standard roof mount. So just depending on the project type will affect that payback period.
Which gets us into how we go into designing these projects. And we'll start first with how you design for new builds with solar in mind here to make a solar ready roof. So it's always tricky to manage competing objectives for any type of construction project. Every goal seems to have the most important relevance to that specific firm or team that's working on it and wants that part to be prioritized. If solar is called for in the new build, then understanding that end goal of the solar system will help steer any architectural design considerations that produce a rooftop for solar EPCs to then design that system on.
And we'll show a few examples on the following slides. Obviously, solar is best suited for the large flat areas. So oftentimes when we get initial drawings, if we're working with a skinnier apartment building that has a lot of rooftop units in the middle, our question is hey, like can some of those rooftop units be placed elsewhere, also to prevent shading. The solar systems do add the dead load, so we need to make sure that we can have that structural sign off to support the weight. Generally for flat roofs, we're using a ballasted roof mount, and that weighs between 3 to 5 pounds per square foot. Whereas the standing seam metal roofs and the pitched shingled roofs, you don't have that heavier racking system, so that's usually closer to 3 pounds per square foot. And then is the project calling for a certain amount of solar energy production, or other goals? So those are the type of questions that we need to know upfront to see if we can even reach that target. Sometimes, we'll have consultants come to us saying, hey, for OAQDA or for some other financing or grant, this system needs to produce X amount of kilowatt hours over the course of the year. And then we're able to say, from the rough drawings, hey, we're maybe just half of that with the current layout. Or maybe we can meet that goal without rearranging any of the rooftop units. So is how can a solar firm adjust the design to meet your production goals? Well, again, that's where it's nice to get in earlier in the process, because we can really work with you to help meet the goals, or say like, hey, this isn't realistic with the current layout, and these are some recommendations that we have. So really just looking for that communication that will support all parties involved and help ensure that you have a safe and successful project for the customer.
So sharing drawing sets early and often will help set that stage for a solar engineer like Nathan to begin designing the system. And building plans unlock that key information that provides us as solar EPCs with the relevant details that delivers that realistic solar system that helps achieve those goals, or to be honest and say, this might not work. Here's some suggestions to change things. So as any plans change, like any construction project does, and those drawing sets are updated, it's always important to continuously provide those updates to keep the solar EPC in the loop and confirm that that solar system is still achieving and meeting those project goals.
And Nathan's had a lot of experience with, again, getting in on the communication on the earlier side, especially for new builds, City of Loveland, Republic Water being, examples. We've had some new apartment buildings go up. So do you want to touch on some of these points here?
Yeah, depending on the building type, we can provide, the load profile that we're intending for the array. For the kind of general holistic, 30-degree tilt facing south is ideal for pretty much all arrays in this area. Obviously, for commercial rooftops, we're pretty far off from that with the 5 and 10-degree tilt angles that Monica had talked about. But the big issue that we look for is shading. How big are those rooftop units? If there's a big cooling tower on the roof that's going to cast a shadow for the majority of the year, then that's area we can't use. Can we push that to the north, or even if there's smaller rooftop units, condensing units, can we aggregate those in a way that isn't gonna, make our array kind of all mismatched pieces all over the roof? All those things can affect the size and the shading of the array.
And then I know, like, relative to the electric room too, and that was something that we caught earlier on with like Republic Wire and DHL as an example, to like make sure that all the equipment is close by.
Correct, yeah. For some of the bigger roofs we work on, if we're not using that entire roof, or we're talking about bigger warehouses, we can put the array closer to that point of interconnection, which is where that solar will tie in to the main building. That's important early in the design phase. If we can get conduits put in place to help facilitate that during the build, that will typically lower your costs. There's also exterior solar disconnects that have to be in place near the meter. Duke is kind of being a little more stringent here lately with that distance to the meter. There can't be parking that could potentially block that disconnect from that meter locations. So there's stuff to think about with solar disconnect location. Also, the load side versus supply side interconnection. If the main panel of the facility or the main switch gear is large enough and has capacity for us to tie in, we can tie in up to a 20% circuit breaker in that main gear. If we can't do that based on the gear sizing, we can do a supply side connection, which is a little different. It allows us to interconnect the bigger solar array. Service voltage is very important. Typically on commercial rooftops, 480 is the best for solar. The 208 inverters are a little less common, a little smaller, so it usually increases cost. We can provide step down transformers that would go from 480 down to 208 for that interconnection if need be, but that still adds cost to the project. Those are kind of some of the high level design considerations that we're looking at. Obviously, getting the main architectural, main electrical drawings will help us to come up with a realistic expectation on what to expect from the solar and how we interconnect that. And the sooner we can get that information, the faster we'll be able to provide that information back to you guys.
So on the next slide here, you know, another component that we run into is, you know, there's a difference between just tying in behind 1 meter for one offsetting, you know, one large load versus working with apartment buildings where you have multiple sub meters and the building owner still wants visibility to what each tenant is using. So we've worked to kind of determine the best way to tie in between the main utility meter and then the sub panel that feeds into the sub meter, so that again, solar will reduce the total electric bill, but you still have visibility to what each of the tenants will use, and they may be using grid power or solar power or a combination of both. But the tie-in and the location of the equipment is a big consideration here. So the picture here is, we mentioned in the previous session that OAQDA has been a popular financing option. So again, this is where we took the approach of minimizing costs by just having one point of interconnection. But it helps offset the load of the meter that feeds into the sub meters of the facility. Otherwise, like what we run into oftentimes with existing builds is there's no way to cost effectively put in solar. You would have to have, you know, 30 plus interconnections, at which point, you know, it doesn't really make sense to do. So again, just trying to catch that up front and see what could be added to affect the new build design. And then this is the drone footage of that previous like rendering of the building. And then after getting that electric bill, we could see, yep, the energy usage or the grid usage is still high during those winter months, but it goes down drastically during the summer months when the solar produces the most energy. And then this was a recent new build that we did. Again, you know, Nathan referenced, we were just using a smaller portion of the roof. You know, if we're preparing for a phase 2, sometimes there can be extra conduit to add. Sometimes building owners aren't looking to do the full project at once. They want to split it up into phases so we can prepare for a phase 2 later. And then the tilt of the array will affect production, but we're also taking up more space if we have like a 10-degree tilt versus a 5-degree tilt. So again, it's determining how much space to work with, understanding what the production goals are and like the long-term goals of the customer.
So we keep talking about why it's important to work with solar EPCs early, and we want to make sure to mention, you know, a little bit more about why. And that's really because we do specialize in this scope, and especially solar EPCs that have in-house engineering staffs and, you know, principals like Nathan here will be working with solar specific software that makes that designing a lot more easy as well as more accurate for what you're providing back to the customers. So we've seen new build projects that might use a template or a default solar system setups in those early stage drawing sets. And then when solar engineers take over and we utilize our softwares here, it turns out that the system doesn't actually deliver on those original goals or might not actually be viable.
You know, we've seen a range of different designs over the years, and you know, essentially what we want to do is just work closely with our in-house engineers to save time and headaches for the customer and costs, so that we can work with what the realistic, you know, expectations are, and design the system according to the plan. And so with the solar specific software, solar EPC can adjust as the building needs change, or as drawings change, and then we can deliver updated data pretty quickly and then check that against the project goals.
Yeah, and that's something that's very site specific and we can create that proposal and get a very accurate production estimate.
Now, ultimately here, adding solar into that total scope of work within the construction process might not be familiar to different general contractors or other firms that are working on that project. Behind the meter solar processes will always start with that approved interconnection agreement that unlocks the rest of those steps. So with those confirmed plans in place, engineering drawings can continue to progress, the equipment can start to be ordered, and then the project execution team can take over and deliver a safe and successful project for all firms and for that end customer.
Yep, and by coordinating with everyone involved, especially on a new build, we can help lower the project costs and shorten the timeline for the customer. Chris mentioned the interconnection agreement process. There have been some times where the customer wanted a project to be expedited and they didn't want to wait for the interconnection agreement to come back with the utility. They had enough confidence based off of our past success. And we have to realize like, hey, these are all the risks associated with moving ahead and, ordering equipment. But as long as we can be upfront with that, and again, understand what the overall goal of the customer is from a timing perspective as well.
Yeah, and that's something that, depending on your project size, can be lengthy. With Duke or the other, utility that you would be interconnecting with. So that the earlier we get that interconnection agreement in the queue, the faster we can get that approval. Sometimes those approvals come with cost from the utility as far as, if you're looking at a 2 megawatt rooftop project, sometimes the utility can come back with upgrade costs that they'll need to perform on their side to allow that production of solar to go back on that grid. So there are instances, some cases where we have to downsize projects or put in curtailment controls, which can be additional costs to play nice with the utility and get them on board for the project.
So early communication that's carried throughout the entire project is extremely relevant so that we can help create those smooth processes as well as lower those costs. Things like electrical gear being laid down, or if equipment can be shared, different site laydown areas, or just overall accessing the site will tie back into the overall solar EPC cost and other parts of the project budget.
I know we want to leave time for questions here. We just have about 5 minutes left, so I'll quickly go through this. Different projects of different sizes can take up, different time frames. I'd say on average, it'll take about 9 to 18 months, depending on the size of the project from phase 1 to phase 6. And, the sooner we can get the electric bill, the sooner we can get single line drawings. For ground mount, a geotech is always nice to have, or underground utilities. Like Nathan said, the determining factor in a lot of cases is just that interconnection application. And sometimes for the larger system sizes, getting that impact study complete as well. The actual construction process is usually just a few months, again, just depending on the project size, but it's really waiting for like the permitting, the utility approval, and ordering those long lead time items so that we can be prepared for construction.
So our last learning objective here is touching on how we include solar with building renovations for current buildings. Now, renovating the current structure and adding those solar needs to be carefully planned, just like with new builds, as that building goes through different changes and renovations and updates are going to impact that solar system and what can be designed and installed. So for example, if electrical gear is changing, then that solar EPC needs to know what is changing and how it fits. An up-to-date one-line or single-line diagram should always be shared, just like architectural drawing sets. That helps keep those engineers in the loop here and confirm that that system can still be tied in the way we were thinking with that interconnection, and continue to work towards that solar production goal or overall solar system goal that was discussed up front. And if the roof's going through updates, then we need to understand what's changing there as well. So it's vital to ensure that that structural capacity for the roof is going to be able to fit that solar system. And any renovations that impact the solar production or how it's going to be mounted will be considered by folks like Nathan here to adjust that solar design and meet those production goals. So if roof obstructions exist before the renovation, like Nathan mentioned, and have shading, and they can be removed during renovation, that provides more space and less shading for that solar system to go ahead and produce more energy.
And I know these are some of the upfront considerations, but a good question that came through was more so looking at this as a long-term investment. So the question was how much maintenance and management of the solar system is needed after this system is installed for a commercial building.
Yeah, for the O&M, that's a package that Melink can provide. Typically, that's a once annual walkthrough of the system on the roof. We provide a monitoring software package that's available from your phone or anywhere you have a local internet service that can give you up-to-date information as far as production alerts on issues with the system. So it's really not a whole lot from a year to year maintenance on these systems. They for the most part sit up on the roof and work.
And one of our, longest time customers, the Cincinnati Zoo, who we've done 5 or 6 projects for over the past 15 years. We've done some on-site training with them before, when they get new staff. And so that, they're familiar with how the system works and, what to expect, such as like when the inverter goes out as an example, and when those need to be replaced.
And with these renovations that we're looking at here, the solar system is going to tie in for those energy consumption or offset goals. So understanding with the current bills and the current usage of the building is important, often utilized with just 12 months of electric bills, or even better is the 15-minute interval data that shows the actual usage pattern across the day there. And renovations that can change how the building is using energy are going to be needed to communicate it back to the solar EPC. Providing those real data to make those assumptions helps lead us to a successful solar system design and narrow down the actual size that we need. So for example, are new efficiency measures being added that lowers that usage, or is new equipment being installed that's going to increase that usage and load profile?
And then we're going to just quickly go through a local case study in longstanding manufacturing in Westchester. So the reason why they were considering solar was because their supplier rates were jumping over 40% from when their last contract was up. They had European customers that had been requesting more carbon reduction and energy efficiency measures. And then with the 30% tax credit, the bonus depreciation, again, them being an S Corp, there were a lot of incentives that took place here. They also opted into the selling reps, and they're always looking at how they can reduce these costs in the long term. Energy being one of the things that they're gonna have to continue using as long as they're in business. And so, how do you lock in a lower rate? So this is an example of what our initial analysis looked like before the structural analysis. Their goal was to get to net zero energy, and this was after an LED retrofit. This was after other energy efficiencies had taken place. Energy usage was ramping up as the business grew, so just understanding what those new baseline assumptions that we built into the analysis. But after that structural analysis took place, the system did downsize. And we eventually, on that building, on the picture to the bottom right, the building with the older roof, that was eventually replaced, and that's a long-standing building as well. And then after this phase 1 project, they ended up replacing that roof and then installing solar on this south-facing pitch of that other building. So you can see from that, from after the system was installed in that first building, this is what the electric usage looked like before solar. So they were consuming roughly 414,000 kilowatt hours. And then once solar was in place, that their energy usage dropped by about 80%, from, from grid power, because the solar was producing so much energy, especially during the summer months. It actually helped with net metering because he got some negative, electric bills that helped offset other charges as well during April, May, June, and July and August. That you can see there where that he was charged $0 from the utility.
So we know we're at time here. Want to be able to help answer some questions. We'll be sharing these slides out afterwards as well, and making ourselves available to anybody that's got a current project calling for solar or hoping to add this tool to their belt there to take forward in your own firm and your own practice as a new value add. Do we have any others that are in the chat, or do we have any specifics that anybody's thought of since then? Not seeing any right now.
Thanks for your time today.
Yeah, we'll be able to share everything out there. If questions do arise, please feel free to reach out to us. We appreciate the time that everybody spent with us today, and anybody that joined last week as well. Hope everybody has a great rest of their Tuesday, and enjoy.